Here is the TinkerCAD simulation for Detector Gadget. Detector Gadget is a drone and it has 4 propellers, and they are set up as propeller 1, propeller 2, propeller 3, and propeller 4. There's also temperature sensors, one in the nose, one on the left, one on the right, and one on the tail. And then it has a distance sensor on the bottom, and that is to judge the distance between the ground and the drone. If you don't know how a drone operates, you'll see these are tagged as the propellers 1 and 4 run counterclockwise, 2 and 3 run clockwise, and I just flagged that because you will see the numbers in reverse, but that's how drones operate. And the distance sensor, it is measuring in inches, but imagine that the inches are actually feet. And you'll see everything is set up over here in the code, and we set up all the variables. We initialized all of the pins. We have a pretty short, clean loop. We just start with setting up all the temperature read and conversion to Celsius. And then we have a couple while loops, and then I get into if else if loops, and then one if else loop here, and then that is it. And then it's pretty clean because I am calling all of these different action functions down here to actually keep the primary code cleaner and easier to work with. So let's get started. Let's zoom in so you can focus on the propellers while this is running. You'll see that all of the propellers are currently maxed out because right now we are less than 95 feet. And so as I go up, if I surpass my comfort space, of 105, you'll see that they've all dropped down, and so now we're actually throttling down. If I'm right in the middle, we are going to move out of the while loops because we have the height we want, and we are going to now move into the temperature zones. The specific purpose of this whole first if else if statements are making sure that the fire is on the left side of the drone. And so by measuring all of the different sides of the drone, it will continue to rotate until the fire is on the left. So you'll see if the fire is on the front side, you'll see it's actually going to yaw clockwise. And let me turn this back down. And then you'll see if the temperature is on the right is the hottest. Once again, it'll yaw clockwise. Bring that down, and if the temperature's in the rear, it's actually going to yaw counterclockwise. Basically, just what's the quickest way to get the temperature on the left-hand side. Once the temperature is the highest on the left-hand side, like it is now, it will pitch left or right to get so the temperature is between 90 degrees and 100 degrees Celsius. And once you can see right now it's pitching left. If it overshoots and gets too close, it'll pitch right. Once it's right in the sweet spot, it will send a coordinate back to base in the other robots, and then it will move forward for 2 seconds and send another one. And it will continue that process all the way around, making a perimeter of the fire. And you'll see at any point, if the temperature in front gets hotter, you'll see it actually starts yawing again. So it's going to turn, and once it's turned correctly and it's back on the left-hand side, it will send another print, and that's what it will go through on and on. If for some reason it falls below the actual height, it will recorrect itself on the height, and then it will go back to sending points.